Morning everybody, or afternoon, so you don't have to watch these things in the morning. So today we are going to look at multiplying and dividing in modulus argument form. It's going to be relatively short in terms of explanation today, and more time for exercises. Yesterday we looked at how to multiply in modulus argument form and derive the formula. Hopefully you guys managed to sort the cosine issue out for the double angle formula for that one, not double angle formula. I can't know what it's called now. Compound angle formula, that's better. For cosine, the cos theta 1 plus theta 2. Today we're just going to have a look at dividing as well, because there's a rule for dividing. And then we're just going to have a go at two examples, and then I'm going to let you guys get on with exercise 5.2, I think it is. So, yesterday we noted that these things were true. We noticed that if we had the product of z1 and z2 and then took the modulus, that was the same as taking the modulus of both of them and then the product. And also we noticed that the argument of z1, z2, so the argument of the product was equal to the sum of the arguments. Argument of z1 plus argument of z2. There's some stuff for division as well. You can see it quite quickly from this sort of thing here. So if I was to say z1 over z2, took that in modulus, that is the same as z1 over z2, oops, there's z2. They're both in modulus. And not too surprisingly, the argument of z1 over z2 is equal to the argument of z1 take away the argument of z2. You can show those relatively easily. Feel free to have a go at that. If it doesn't make sense, I think there might be an example of how to show it in the book, or just get back to me and I'll just run through that with you. So those two things are both really useful, and you need to know those for your exam. And you may need to multiply some complex numbers together for your exam as well. So let's just try an example of this. So let's let z1 be equal to 3 lots of cosine 2 pi over 3 plus I sine 2 pi over 3. And let's have z2 being 4 lots of cos pi over 2 plus I sine pi over 2. Okay, so just have a quick go at these. Can you find, first of all, what z1, z2 is? The product of those, and then secondly, can you find out what the z1 over z2 is? Can you just have a look at those for me, please? Pause the video and then check your answers in a moment. Okay, so hopefully with z1, z2 you managed to do that pretty easily. So z1, z2, I need to take the moduluses of both of them and times them together. There's the modulus of there's the modulus of z1, there's the modulus of z2. So that's going to be 3 times 4. And then it's still going to have the same form because it's a complex number. I've got cosine of 2 pi over 3 plus pi over 2, because the arguments are added together when I multiply, plus I sine 2 pi over 3 plus pi over 2. If you feel like you're going to make a bit of a hash of this, what you can do is say modulus z1, z2, then find the argument of z1, z2, and then write this out again afterwards. It's up to you, the way it does not matter. So all that together is going to be 12 lots of cosine 2 pi over 3 plus pi over 2. So that's 3, 6 plus 4, that's 7 pi over 6. Plus I sine 7 pi over 6. And I'm guessing you guys have probably got minus 5 pi over 6 because you said, but Mr. Ball yesterday or the day before, you said that the argument has to go between minus pi and pi. As far as your course is concerned, yes, we generally do that. So you should convert this now and say, okay, well, 7 pi over 6, if I think about how far that's round, it's 1 pi all the way around will get me to there. If I went a little bit more, an extra 1/6 of a pi, that would be the same as coming around this direction by minus 5/6. So that would be cosine minus 5 pi over 6 plus I sine minus 5 pi over 6. Every now and again, they can try and confuse you with this. Now, if you think about what a cosine graph looks like, that not the question that's written at the moment, they could give you this here and say write this in x plus iy form, and that would be easy enough. Or they could be really sneaky. And this is an aside from the question. The question's finished. That's absolutely fine. But what they could do is, as cosine, think about what the shape of cosine looks like. Cosine's symmetrical. So if I had cos minus 5 pi over 6, which is about there, minus 5 pi over 6 is about there, it's actually the same as cosine of plus 5 pi over 6. So they could give you a question where they'd say express in x plus iy form 12 cosine 5 pi over 6 plus I sine minus 5 pi over 6. Obviously you couldn't just do that straight away. You'd have to make sure that these guys had the same argument. The other thing they can do is sometimes they'll have this as a minus here, but these angles are the same, and you have to rejiggle that then. You have to change this one and then change that one. But generally, from what I've seen from the MEI, they don't do this in the exams. However, be aware of it, that there has to be a plus sign in the middle here. And if you, according to this anyway, if you have cos of minus an angle, it's the same as cos of an angle because of the symmetry. However, that doesn't work with sine. If you have sine of minus theta, that's the same as minus sine theta. So just to be clear, the question which we had, the example was finished here for part 1. This is just an aside. This has to be a plus sign. If they're going to go back the other way, that has to be a plus sign there. You can change this to a minus by using this idea quite easily. Or if this was a minus here, it's the same as having the minus in there, and then you could change this one. Hopefully I haven't confused you too much. Get back to me if that does confuse you. I don't think you've got any questions coming up on it, so it's not the end of the world, but something to be aware of. Okay, and then part 2. Part 2's really easy. It's exactly the same thing, basically. It's just obviously we need to do takeaways this time. So just in case you are someone who prefers to do this a different way, if you wanted to find out what Z1, Z2 is, I would normally just do an arrow like this and say, okay, well, the modulus of Z1, Z2. Just to be clear, that arrow doesn't mathematically mean anything. It's just me trying to say I'm not working it out exactly, I'm just doing some stuff. So Z1 over Z2, I've realised I've actually just looked at that page and didn't actually pay attention, is going to be the same as Z1 over Z2, which was 3 over 4, I think it was. I'll just double check that because I still haven't paid attention. Yes, it was. And the argument of Z1 over Z2 is going to be the argument of Z1 take away the argument of z2. The argument of z1 was whatever it was 2 pi over 3. And then I want to take away pi over 2, which will give me pi over 6, which is 30 degrees, if you wanted to know. And then afterwards, the question would probably say express z1 and z1 over z2 in modulus argument form. So once you found the modulus, once you found the argument, you'd then have to write down, therefore z1 over z2 is equal to 3/4 cosine pi over 6 plus I sine pi over 6. Just one note back on this bit. I think I'm not sure if I went through this bit properly. Well, I went through it properly in terms of trying to convert this into something between pi and minus pi. As far as A level is concerned, that's true that we go between pi and minus pi. However, if you start to study maths longer term, you can just go round in the positive direction always if you want to. It doesn't really matter. Certainly the first time I ever came across negative arguments, I think, was probably when I started teaching, because you don't really need them if you're happy just going round anti-clockwise all the time. Yeah, so it's a matter of preference, but A-level maths generally expects you to do this negative argument as well. Okay, so I think that's probably all we need to do, really. We've done 2 examples. We've talked a little bit about the quotients. So yeah, I think you probably should just get stuck into some exercises. I think it's exercise 5.2. Let me just double check that. It is exercise 5.2. Can you please get all of them done? And I will speak to you again tomorrow about doing loci tomorrow. That's very exciting. Okay, have a great day, and I will speak to you again soon. Ta-ra, bye-bye.